Warning: hydrochloric acid is corrosive. Wear gloves when handling it. Hi guys, this is the second video of my photochemistry series, and today I'll be making another popular fluorescent compound that is, to my knowledge, never posted on YouTube before. The chemical is called guanidinium chloromanganate, and unfortunately it is not as popular as the 8-hydroxyquinoline aluminum complex we made last time, so I cannot find much data about it. You can see in the diagram that the compound consists of a special trimanganate anion, which perhaps gives it its fluorescent properties. Anyways, to make this compound you will need manganese sulfate, potassium carbonate, hydrochloric acid, and guanidinium chloride. The first three chemicals are for making manganese chloride, so if you already have manganese chloride, you can use that and skip a bunch of steps. First, 16.9 grams of manganese sulfate monohydrate and 13.8 grams of anhydrous potassium carbonate are weighed out separately. I overshoot it a bit and added excess manganese sulfate, but this doesn't really matter. Both reagents were then dissolved in a minimal amount of boiling water, and the potassium carbonate solution was added to the manganese sulfate solution. A gel-like precipitate of manganese carbonate appeared, which solidified upon rapid stirring. The mixture was then vacuum filtered. I originally thought that the manganese carbonate would easily oxidize to manganese dioxide when it touches the air, since divalent manganese is not stable in alkaline conditions. However, the carbonate seems to do better than the hydroxide, as it stayed white, while the hydroxide rapidly turns black in contact with air. The precipitate was then washed with water and scooped out into a beaker. Some dilute hydrochloric acid was then added slowly. The manganese carbonate reacts with the hydrochloric acid to produce manganese chloride, carbon dioxide, and water. It is very important to add the acid slowly because, as you can see, the carbon dioxide bubbles are very easy to overflow the beaker. When all of the precipitate dissolved and no bubbles formed, stop adding the acid. I added around 100 milliliters in total. Then, 19.1 grams of guanidinium chloride, also known as guanidine hydrochloride, was weighed out. This salt is notorious for its extremely hygroscopic properties, so be very quick when handling it. It is then added to the manganese chloride solution we just made. The solution is set upon a hot plate and boiled down. As the solution concentrates, it slowly takes on a green tint and then a blue tint. I continued to heat the solution until a bunch of solids crash out, and removed it from the heat. When I shined UV light on the bottom of the beaker, the stuff inside actually displayed some pink fluorescence, which tells me that the synthesis actually worked. I originally thought that there are some impurities which gave the solution its green color and destroyed the reaction, but apparently my product is formed successfully. I filtered the sludge and it displayed strong UV fluorescence just as expected. The product is then scraped out and weighed. It has a wet mass of 18.85 grams. Now, at this point, you might call this preparation a perfect success, but the preparation video I'm following made some really beautiful needle-like crystals instead of my ugly lumps. So I tried to do a recrystallization. I added 10 milliliters of water into the crystals and heated it to boiling. Upon cooling, some needle-shaped crystals did indeed start to crystallize, but they don't have the slightest amount of fluorescence under UV. Puzzled by the result, I boiled off nearly all of the water just like last time, and filtered the solid after it cooled down. This time, the crystals are in pellets, and they are strongly fluorescent just like the product from first time. I scooped out the product in a petri dish and placed it with a dish of anhydrous calcium chloride in an attempt to drying it. However, the product is ridiculously hygroscopic, and the calcium chloride did nothing to it. I eventually transferred it into a vial for storage, and I have 11.39 grams of product, which represents a yield of around 36%. I'm pretty satisfied with the result, and I took some pictures of my product under UV. Anyways, the preparation of this fluorescent chemical was successful. In future videos of the photochemistry series, I will make some more fluorescent compounds such as luminol and fluorescent and attempt photochemical reactions such as cyanotype. Thanks for watching.